Hey guys, welcome back to day 3 of our shortened week. This is our last day of this week since we don't have school tomorrow for Love Friday. So I'm going to try to squeak out the area of a parallelogram and a trapezoid. So I'm going to kind of move through this fast. I'm going to be on page 94. I already have my page set up, so underneath I split the bottom half of my page into 2 equal areas. So I have parallelogram on the top and trapezoid on the bottom, okay? So I'm going to start with parallelogram, and I'm going to just define this real fast. So the big things you need to know about parallelograms is, like a rectangle, it has two sides that are the same. So this side and this side are the same length. So two same length sides. And then it also has 2 same length sides. Okay, and let's see if I can explain this. All of sides are parallel to their opposite side. So opposite sides are parallel to each other. Okay, so that means if I were to extend each of these lines, they would never touch. And so technically a square and a rectangle are parallelograms because their sides are parallel and they never touch. Most times if you see something that's parallelogram that's not also labeled a square or rectangle, it's going to look like this. So it's going to have 2 angles that are less than 90 degrees and 2 angles that are more. But that's not always the case, so I'm not going to write that down for right now. What you do need to know is these 2 sides are the same and these 2 sides are the same. Okay, when we're talking about finding the area of a parallelogram, I'm going to draw this out and you're going to do it, but I'm going to show you on something a little bit larger. So if I have a parallelogram that is 2 meters wide, I'm going to do 2 meters wide, and it's going to be 3 meters tall, and I'm going to do it a little bit off center. So I'm counting up 1, 2, 3, and I'm just going over 1 square. So I'm going to go up 1, 2, 3, and bump over 1 square. So there's my parallelogram. Just like in the triangle, they're going to have a dash mark showing you the height of the parallelogram. So this one is going to be 3 meters tall. So I'm going to show you on a cutout that I have to make this a little bit easier so you can kind of conceptualize this, okay? Same measurements here. But when you're finding the area of a parallelogram that's not a square or a rectangle, you can cut it into pieces because I can't immediately count this stuff up because I have weird parts of triangles here. But what I can do, and some of you might have figured this out just like with the triangle, is I can cut part of this off and move it to the other side. So that's exactly what I'm going to do. I'm going to cut off where this 90-degree angle is, this little triangle here. And if we were in class, we would be doing this with actual squares and rectangles. And what happens is I just move this little piece from here over to here, and I have a rectangle. It's not very well cut out because I didn't use a ruler, but you can kind of see, oh, there's the rectangle. So now I have a complete rectangle that I can easily find the area of because I know it's going to be base times height. So in here, what I'm going to draw is I'm going to just move this over to here, and I'm going to just dot, 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 dot out. And so then I can do base times height. So I'm going to do that. 2 times 3 equals 6 meters. Oh, I should have done square meters. I'll just do it with the 2 there. Okay. So let's do another one just for practice, and I won't have it cut. So let's do it a little bit longer. We'll do 1, 2, 3, 4, 5, and we'll do 2 tall. Oops, And I went too far. So my height now is going to be, I have this, it's 2, we'll do 2 inches, and then I have 1, 2, 3, 4, 5 inches long. So I can take off, and maybe you want to use colors. I'm going to take this off, and I'm going to move this down here. And so now here is my rectangle, okay? So now I can see my complete rectangle right there. And I can do that math. So now I have my rectangle here, which is 5 times 2, and that equals 10 square inches, okay? So the area for a parallelogram is going to be the exact same as a square or rectangle, because a square and rectangle are parallelograms. So it's going to be base times height equals area. Okay, so if you want to bubble that so you remember it, base times height. So you don't have to cut this off every time. You can just know that's base times height. Okay, so if you have the height and you have the base, you can figure it out. Okay, now we're going to get into parallelograms. Parallelograms are a little trickier. They're not quite as simple as a parallelogram. So with a trapezoid, first thing you need to know is it's going to have one set of parallel sides. So when we show parallel, we do arrows, not dashes, because this means they are parallel, and the straight lines mean they're the same length. So we have one set of parallel sides, okay? So that means these two are never going to intersect, but they are parallel to each other. Then you have two sets, sides that are not equal. So this is side A, and this is side B. So A, B, okay? And then you have usually a height, okay? So these two sides on over here, we don't usually label those because sometimes they'll be the same length and sometimes they'll be different lengths. I would also say that sometimes, in most cases, you're going to have 2 obtuse angles and 2 acute angles, but that's not always true. So this is kind of a base definition of what a trapezoid is, okay? So you're going to definitely have a height on each, okay, on every trapezoid. And usually they mark it from the end of one of A's lengths down to show height. Okay, so when I'm finding the area of a trapezoid, I'm going to do some tricky things. And there's lots of ways that we explore it in class, but I'm going to give you what I think is the easiest. So let me sketch this out first, okay? So I'm going to have one that it's going to be 4 tall. 1, 2, 3, 4. So I'm just going to do my dotted line here, and it's going to be like this. So 1 past my dotted line, and then I'm going to do 2 out. Okay. There we go. So this is going to be 3 feet. And then this right angle, the height is going to be 4 feet. And there you go. So that's my trapezoid. So I have this, it looks a little different because I'm, again, not very good at making shapes. But here is my sample size trapezoid. So like I did with the parallelogram, I'm going to cut off part of this and move it around, but you're going to be shocked at where it's going to go, okay? So I know that the angle of this side is the same. So I'm going to be matching some things up. The first thing I'm going to do, I'm not going to cut this off because if I move this over here, it's not going to match up perfectly. And you can see that better on my cutout than over here. So if I cut this off and try to put this over here, it's not going to work. It's going to be really ugly. But what I can do is I'm going to actually fold my shape in half. So I'm going to do that right now. And you're probably like, Ms. Grossen, that doesn't make any sense. What are you doing? Well, okay, just trust me. So now I'm going to cut off, I'm going to cut my trapezoid in half here. And what I'm going to do is I'm going to take, I can either go one place. And you know what I'm going to do before I even do this? I'm going to label my sides. So I'm going to have A, and I'm going to have B, and then I'm going to have, well, I know that's my height, okay? So here's what I'm going to do. I'm going to just flip this over, and I'm going to stick that right there. And when I do that, now I have a shape that I recognize. I have a very lovely, very long parallelogram. So 2 sets of parallel sides. I have 1 set of parallel sides. I have 2 sets of parallel sides. And I can easily find the area of that because I know it's base times height, okay? So let me show you that again. I folded my trapezoid in half, and then I cut it off, okay? And then I took that top part and I'm gonna match this side to this side. So I'm just basically like folding it over. Boop, there you go. And it makes this lovely parallelogram. There we go, I got there. So I'm going to now add, this should be B. B should be closer down here. I don't know why I put it in the middle here. So this is B. That's 3 feet long. And I know that A, which I didn't label, but that's going to be 1 foot long, is going to be down here. Okay. So I'm going to be doing some addition because I need to figure out my new base. And I'm going to be doing some division because I need to figure out my new height. Okay. So if I do this, I'm going to remember I'm cutting this in half and I'm going to fold this down. And so now it's going to look like this. So if this was B and this is A, okay, this was A and it was 1 foot. So now that's over here. Okay, so my new height, because I cut that 4 in half, so my height was 4 feet and I divided it in half. Okay, and so now that tells me that my new height is going to be 2 feet. And now I need to add B plus A because I put A down here. So B plus A is 3 feet plus that 1 foot. And so that gets me 4 feet. So I'm not done. I have to now multiply 2 feet times 4 feet. So that's going to give me 8 feet squared. Okay, so we ran out of space and time to give you the algorithm. So the algorithm for this is going to be, I'm going to add A plus B, so A plus B, and then I'm going to divide, I'm going to multiply that by the height divided by 2. Okay, so I'm dividing my height by 2. I cut it in half, and then I'm multiplying it by the new base. Okay, sorry, this should really be a multiplication. Okay, I'm going to pause this for a second and post your sample problems, okay? Okay, here are your practice problems. You have 2 parallelograms and 2 trapezoids. So here's your 2 parallelograms. Pause it if you need to. And here are your 2 trapezoids. And I messed up counting the height of this, but this should be 6 even though it's 5 here. So 6 centimeters tall. Okay, if you need anything, pop into my office hours. Otherwise, have a great weekend. Bye, guys.